up. So we're talking some more about quartiles from a cumulative histogram. I record all the lessons, so you have access to all the lessons, all the notes. I'll give you the access. Okay. So quartiles break up a set of data into 4 pieces. We spoke about that last lesson. Get a piece of paper out. I'm sure you have some paper. No comments. Alright, and so it's giving us an idea about how the data is spread out. That's the whole point of quartiles, giving you an idea of distribution, spread of the data. That's what we're interested in, and where a particular score falls in that spread. That's the same idea with percentiles. If you fall in a particular percentile, it's dividing it up and seeing how the data is spread, and then seeing where you fall into that. So the lower quartile is also called the first quartile. It can be called Q1. Right? Upper quartile is called the third quartile, Q3. And then the middle quartile is the median. So looked at, and it can be referred to as the second quartile, but often it just means median. Okay? That's what it's about. So to find the quartiles, you find the median, middle score, and then you find the middle scores of the 2 halves. Once you found the middle score, you've broken the data set into 2 halves, upper and lower, and you find the upper half, the middle of that score, and the lower half, the middle of those set of scores. Alright? And so that's the way it works. Now we've got a couple of examples. Don't worry too much about writing that. You should be able to know it. Alright, find the quartiles for this set of data. What's the first thing we have to do with this set of data to find the quartiles? Callum? Put it in order. Good. So let's all put it in order. Harrison, tell me, what's the order?
1, 2, 3, 4, 5, 6, 7, 8.
Good. How many scores are there? Yeah. So which is the middle score going to be? To find the median, what's the middle score? Yeah? Yeah, so there's 11 scores, so there's going to be, the 6th score is going to be our middle score, which is 4, so that is the median. Alright? Now we have 2 halves with 5 scores in each half. What's Q1? What's the median of this half? Yeah, 2. So the middle score, 1, 2, 3, 4, 5 scores. If you have a middle score, you just ignore that. And so 1, 2, 3, 4, 5. And so 2 is the middle score. That is the lower quartile. And then the upper quartile, 1, 2, 3, 4, 5. The middle score is the 6. So this is the upper quartile. Alright, so that's the way that we figure it out if you have a small set of data. Okay, you find the middle score, and then you find the middles of the 2 halves. Give me a sec to write that down if you would like to. Now we can also find from a cumulative frequency distribution table, we can find the median and the quartiles, because we get a total number of scores, and then you're able to work out where the halfway point is, etc., etc. So while we're just trying to, I'm just going to align the board. Okay, so if I go up to this one, here we have, how many scores are there in total in this data set? Good. How many scores are there in this data set? No, there's 6 separate scores, but how many of them are there? 30. Yeah, cumulative frequency total is how many there's accumulated. The total number is 30, so there's 30 scores. Alright, what's the halfway point of 30? 15. Okay, so where's the median going to be? Yeah, between 15 and 16. So there's 30 scores. So the median is between 15 and 16 scores. Right, so it's between the 15th and 16th scores. So we've got to have a look at what scores are where. So one cumulative frequency is 4. So what we're saying is the first, second, third, and fourth scores are here. Alright, and then up to 9. 5, 6, 7, 8, 9, etc. And 10, 11, 12 is here. And then this one we have 13, 14, 15, 16, 17, 18. Where is the median? What's the median score? 6. Yeah, because the 15th score and the 16th score are 6. And so the 15th and 16th scores are 6. So the median is 6. So that's our median, is 6. Now we have, if we look at the top half, we've divided the 30 into a group of 15 and a group of 15. What's the middle score in the top 15? How do we work out what the middle score is? We've got 15 scores. What's the middle one going to be? 7. Well, let's have a look. So you've got to think. So the 8 score is correct, and we're going to have a look as to why. Now, if we have 15 scores, so let's just say, I'll just draw it out for it's a bit tedious, but just for illustration. 13, 14, 15. Okay, we've got our 15 scores here. If I look at 1, 2, 3, 4, 5, 6, 7, alright, and then count from this side, 1, 2, 3, 4, 5, 6, 7. 8 is the middle score. So the 8th score out of 15 is the middle score. Right? And the best way to work this out, instead of drawing out, because if you have 151 scores, you're not going to have to write 151. Best way to find the middle score of an odd number of scores, is what? Minus 1? Yeah. One way. Or what's another way? It's just one. If I add 1 to 15, what do I get? 16. And divide that by 2, get 8. Alright, so the way you do it is, and this always works, you add 1 to the score, then divide by 2. Now to find the middle score of an odd number of scores, this only works for an odd number, you have to add 1, divide by 2, and you find what the middle score is. Now saying that, we are looking for the 8th score. So what's the 8th score in this data set? Right, what's the 8th score in this set of data? It's 4. So 3, the first 4 scores are 3, and then 4 is the next 5 scores. Now the scores which are 5, 6, 7, 8, 9 scores are all 4. So 8, which means that the lower quartile is equal to 4. Lower quartile is 4. Good. And what is the upper quartile? What's the upper quartile going to be? This is what you've got to think about. You've got the upper 15 scores. we got? What's the upper half? From 16 up to 30. 1, 2, 3, 4, 5, 6, 7, 8. The 23rd score is Q3, which corresponds to which score? 7. So 7 is our upper quartile. So the upper quartile is 7. Alright, you find that by following through, breaking it into two halves, finding the median of each half. Now, somewhere. Now, we can also find quartiles from cumulative frequency histograms and OGs. What's an OG? Alex, what's an OG? Okay. What's an OG? Yeah, polygon of the cumulative frequency polygon. Yes.
He mentioned it, but we were in the graphics next to what it was, so no one paid any.
Yeah. This shows I do actually mention things. You learned it last year. All those who were in my class. 1, 2, 3, 4, 5. We went through this. We did. It is the cumulative frequency polygon. It just is. Don't worry too much. So you divide the vertical axis into 4 and trace across to the OG from each quartile to see what score corresponds with that quartile. Alright, so the basic thing is you're using this graph to then find out what the quartiles are and what score corresponds to. So let's have a look at this graph. I'm going to draw in an OG. So I would like you to draw this graph, please. I'm going to draw in this cumulative frequency polygon. Alright. Please draw the graph. Give me some kind. Come on. Can't turn around and say you never learn anything when in fact I do and you choose not to pay attention. I'm going to start saying that you need to write something. Now, you can listen up here. The way that we do this is this cumulative frequency histogram. There's 50 scores in total. What's halfway of 50? Yeah, it's 25. So I can actually mark on here the 25th score. And that's my median, which I can write as Q2. So what I do is, I mark my halfway point, and then I go across, trace across from there, to where I hit the OG here. And then I can trace a straight line down, and then this is my median score here. Right, that's the way that I do this. I go across and I hit it. Now, if I look at the first half, the lower half, what's half of 25? 12.5. So 12.5 is going to be approximately here. And so I go across, hit the yogi, and then I go down. And this is my reference point for the first quartile, which is Q1. Alright, so that's Q1. Then again, we go 12 and a half. It's going to be somewhere around here. Halfway between these two. And we go across. And this is our reference for Q3, the upper quartile. And I trace that down. And do it like that. Now what I can do now is, I've got my 3 spots along the bottom. What kind of data is this? As in, what do these numbers represent? Class centers, which means it's group data. Okay? So which means that these class centers are just the average of the upper and lower limits. So I'm going to actually estimate what the 3 quartiles are. Alright, so I'm going to estimate the quartiles. So I've got Q1, Q2, and Q3. So Okay, because it's approximate, because we're not sure exactly, because we don't know where exactly the scores are. What do we estimate for Q1? 28 is here, 35 is here. What's the estimate for Q1? Yeah, 30, 31, that's fine. Either one. So let's say, let's see, 30.5. Just for the sake of fairness. Okay, so these sort of questions, as long as you're within a certain range, it's fine. Okay, what about Q2? What's the median? What's the estimate for the median? Brandon? 40? Yeah, it's good. About 40 is fine. All right, we're estimating 40. And what about for the third quartile? 50, 51, let's say 50 and a half. All right? And so that's what we're saying is the quartiles from them. Now, if it's not group data, if it's just from a normal data, if I can say it like that, from just an ungrouped data, then if it falls within that column, it's that score. But in this case, we estimate it because it's group data. So there's a slight difference between group data and ungrouped data, but the method is the same. You mark the halfway point for the median, you mark the sort of the quarter, the halfway between halfway and the top for the upper quartile, and the same for the lower quartile. Alright, so this is a technique where if you're given this, you can just mark it on the graph and see very clearly where the median and the quartiles are. Alright, any questions there? Good? Nice, make sure you have it nicely marked on the graph that you've drawn about how you draw the line across and see where it falls on your graph. Now, carrying on, we're going to talk about range. The range of a score is simply the highest score minus the lowest score. Alright, and we talk about the range as a measure of the spread of data. Okay, how spread out or how condensed a set of data is. Now, what is the range of this data? Of this example? A minus 2. So that's important. You don't look at the frequency. You don't look at this. You don't look at this. You're just looking at the scores. The lowest score is 3. The highest score is 8. So the range is equal to 8 minus 3, which is equal to 5. Right? So that's what the range is. If you have just a set of list of numbers as a data set, simply the highest one minus the lowest one. Right? I think that's pretty straightforward for everyone here. Now, the last thing we're going to look at is the interquartile range. What's the interquartile range, Mitchell? No. That's alright. Keep it on. Yeah, upper quartile minus the lower quartile. Alright, so Q3 minus Q1. Upper quartile minus the lower quartile. And this is also a measure of spread, but it's only taking into account the middle 50%. Remember how we talked about on Monday that the quartiles breaks the data up into groups of 25%? And so your interquartile range is the boundaries of the middle 50%. The middle half of the scores is between the two quartiles. So in this way, the IQR, which is just abbreviation, can often be a more accurate measure of spread than the range. Alright? And the reason for that hopefully will be evident in this example. So, can you go ahead and find the range and the interquartile range of these two sets of data? Which means you have to find the quartiles, the upper and lower quartiles. So go ahead and do that, please. And then we're going to talk about it in a moment. What's the range of the first one? Yeah, it's 14. So the range for this one equals 18 minus 4, which equals 14. And what's the range for this one? Yeah, it's also 14. It's 15 minus 1, which equals 14. Bella, what's the interquartile range of the first one? Oh, yeah. So how'd you get 4?
9 minus. Oh, well, yeah, 9 minus.
Yeah, 9 minus 5. Okay. 9 minus 5 is equal to 4. What's the interquartile range of the second one? Callum? 10. So 10, 12 minus 2. Now, the thing about this is, which of these, the range or the interquartile range, which is a better indicator of the spread of this data? Why is it the interquartile range? Yeah. So that's the idea. The interquartile range represents this one better because most of the numbers are between 4 and 9, and then it jumps out to 18. So the range is 14, but actually the majority of scores are in the lower half of them. Whereas this one, which is a better indicator, range or interquartile range? Range. I mean, it's a bit hard to say exactly, it's such a small data set, but the range is much more representative because they're all sort of spread out across the whole range. Right, so in this way, the different measures of spread give you a different idea. Sometimes the interquartile range is better because it shows where the majority of scores are, or the range can be a better indicator of spread. But more often, it's the interquartile range, which is a better measure. Right, so basically that is what we're going to talk about. So in the booklet that I gave to you,